All right. Good morning and good afternoon, everyone. We'll give everybody just about 1 minute before we jump into some introductions and get the presentation started for today. All right. So we are live. Good morning, good afternoon once again, everyone. My name is Chris Gardner. I'm with HashiCorp. Today we are joined by Ray Cowan, who's a cloud specialist on the global black belt team over at Microsoft. And today he's going to cover migrating from VMs to Kubernetes using HashiCorp Consul as a service on Azure, which is currently in public beta and will be going GA relatively soon. And with that, Ray, I'll kick everything over to you and let you get us kicked off for the day.
Awesome. Thanks, Chris. Hi, everyone. Thanks for joining us this morning. First session of the day. So thanks for joining. Depending on what time zone you're in, it was probably pretty early. I'm out of Toronto, so it's nice. I got to sleep in a little bit, and here I am. So as Chris mentioned today, we're going to be talking about migrating VMs to Kubernetes using HashiCorp Consul Service, which runs on Azure. I'm Ray Ko, as Chris mentioned. I work for the Azure Global Black Belt team at Microsoft, where I work as a cloud solutions architect, essentially, working in cloud native and open source. So let's get started. There we go. So what we're going to cover today is what is HCS, or HashiCorp Consul Service? How does it actually work under the hoods? Not too deep technical dive in there, but some information that you might find useful in terms of how to actually approach it, how you should be thinking about it, especially if you're a security conscious organization. What are the benefits of it, and does it actually fit your model in terms of deploying it? Because you don't have to go with HCS necessarily, although it's a great service. You could roll your own depending on what your requirements are. I want to go through a quick deployment walkthrough in terms of how you actually spin it up right now. As Chris mentioned, it's currently in beta, so there are some things that might change once it goes to GA, but generally speaking, the process will likely be the same. We're also going to take a look at common scenarios in terms of deploying not only HCS, but Consul in general, how it fits in your organization, the mix. Is it purely a VM environment? Is it purely a Kubernetes, or the cloud native way of doing things? And ultimately, the more pragmatic approach, or the likely scenario, is it's going to be a mixed environment. It's not going to be all Kubernetes. It's not going to be all VMs. They'll have to all coexist for various reasons. And lastly, we're going to take a look at service mesh interface quickly in terms of what it is, how does it fit into the mix of things, how does it integrate with Consul, and how can you leverage its ability to help you, in essence, migrate if you need to from VMs to full-on Kubernetes, or how do you sustain this mixed environment for you? And of course, we'll leave time at the end, about 15 minutes, for Q&A and next steps. First off, before I get into the overview, I actually had a demo environment set up, and of course, with all good demo environments, I wanted to tweak it last minute, and it fell on its face. So I've already talked to Chris this morning about it, and we're going to come up with some content after the fact to walk you through the various pieces of the actual working environment once it's up and running again. But I do apologize for that. This will mostly be an overview in terms of the service itself. I will show you the configuration. I will show you some terminal commands that you need to run in order to get settings and what have you, but it won't be a full end-to-end experience. The good thing about the demo is that when it does work, there's really not much to see. You basically change a couple of files, and the service runs as you would expect. It really, other than the fact that it's a managed service, you would use it the same way as you would roll your own Consul cluster. All right, so what is HCS on Azure? So HashiCorp Consul Service, it's a fully managed Consul cluster. So the servers themselves, you can choose between 3 and at max about 5 in terms of best practices servers. You can configure that in the actual dashboard when you're deploying the cluster itself. But the service itself is managed inside a HashiCorp subscription. So in Azure, the subscription is basically that top-level billing model. You can have multiple subscriptions within your organization, but it gets deployed inside a HashiCorp, essentially, subscription tenant. Now, what happens for you in this experience is that they'll manage the life cycle of that cluster for you. We'll get into that in a sec. The benefit of HCS, of course, while it is a HashiCorp managed instance, it is billed to you via Azure. So it feels like a native experience. You procure it, you sign up for it, you activate it as you would expect, either through Portal or depending on your organization's preferred way of procuring things or deploying or provisioning things. You could use ARM templates, or since you're here viewing a HashiCorp video, likely Terraform. So that is available to you as well. Best practices by default. So the same defaults that are usually there for Consul are there from an enterprise perspective. Of course, HashiCorp, the engineers are going to back that. They're going to put in the best practices in terms of maintaining the cluster, upgrading, rolling, scaling, etc. As needed. It is ultimately designed for AKS and other Azure compute environments to discover services across these environments. Again, that hybrid scenario or that mixed environment I was mentioning before. And you can eventually, it's coming soon, connect to on-prem environment as well. All right, so that's sort of the high-level points to talk about it. Under the hood, though, let me switch this so that I'm out of the way. The way that it works is that you can basically procure it in the Azure Marketplace. And if you're not familiar with Azure Marketplace, we'll walk through it in a second. But it's basically our marketplace within the Azure Portal. You basically can search for a number of services. You can search for network virtual appliances or firewalls or other supported vendor products that are out there. In this particular case, you can search for HCS in the marketplace listing. What happens there is it gives you a browser-driven UI, lets you fill out a couple of fields in terms of what you want to configure, how you want to name the service, and then what happens is that configuration gets kicked off to a HashiCorp control plane. Basically, it's a server or a service that they're running again within their subscription. Takes your configuration within your environment, kicks it off to their particular workflow manager, and then what that manager will do, without getting into too many details, will deploy the actual cluster, which is a set of VM scale sets in Azure. So these are not just plain old VMs; they are a specific type of compute service within Azure that will deploy the cluster, the Consul master clusters themselves, so the primary clusters. At a minimum, it's going to be 3. You can configure this, I believe, up to 5, and that'll deploy a virtual network as well, which these servers get deployed into. That is in a resource group that's, I believe, just isolated just for your account. And what happens is that you must explicitly opt into what we call VNet peering, essentially joining the 2 virtual networks, your particular virtual network that you are running in your environment. This could be a hub network. This could be a spoke network. It all depends on how your network topology is. But essentially, these networks are joined together. The key things to keep in mind, of course, and you do have some control over this, is that the VNet CIDR ranges do not overlap, or they're not colliding with each other. They have to be non-overlapping addresses. So, you could have a 10.0.0.0.24 and a 10.0.1.0.24 network. All right, one for your network within your own subscription, and then one for the actual HashiCorp VNet as well. And that's totally fine. And so once they're paired together, what happens is that you can then communicate back and forth across the networks accordingly. More importantly, you're going to be communicating with the private FQDN or endpoint that is associated with your HashiCorp cluster. And we'll see that in a second in the configuration. So just like you would connect to or do a retry join in your own cluster, you basically try to retry join against that private FQDN or domain name that gets provisioned for you. All right. So we're going to quickly go over to the marketplace just to see how it's spun up. Hopefully this view works as expected. So if you've never seen the Azure Portal before, this is basically what it is. All cloud providers will provide you a web-based UI to provision services. In this particular case here, I have some already pinned: virtual machines, VM skill sets, Kubernetes services, etc. The view that we have open right now is the snapshot of resource groups. These are high-level logical groupings of our resources. Think of them like folders on your file system, right? So I would group VMs within one resource group. They're, sort of cohesive unit of resources that need to be deployed. You can spin up as many resources groups as you want. In this case, I've already created several for the demo, which fell flat this morning, but I'll show you on another date. I've got the HCS beta resource group that's already been deployed, and within it, I have the HCS service that's already deployed into it. And you'll notice that it's got this, it's a unique icon. I don't think it's unique necessarily to HCS, but it's for Azure Managed Applications. And we'll click on this in a sec. But what I wanted to really show you is that when I'm in the actual resource group itself, you'll notice that this is the only resource that's in here, but I can add additional resources. So I can either click add here, and then this will basically pop up the marketplace search. And what I can do, type in here is HCS, enter, and I'll start searching for things that will match HCS. Now, right now, because it is in preview, or it's in beta, and I signed up for a pre-preview version, pre-preview, yeah, I think that's proper in terms of how it's called. You'll notice that there's actually 2 HCS services in here. And likely in yours right now, if you're going to try it in the public beta preview, you'll only have this first one. So it doesn't have the preview in brackets, just this one here. So if I click on that, I basically have 2 plans right now. I'm just going to click on the beta testing one, and I'm going to hit create. Once this goes GA, of course, you'll see plans and pricing. Right now, this is basically $0 because it's in beta. This, of course, won't be 0 when it goes GA. At least likely not. Someone's got to make some money somewhere. And then what we do is we hit create. So once we hit create, again, this is a form that you just fill out. You can choose the region where you want the clusters to be deployed. I believe this is the starter set on here, but I don't know if this is like an inclusive list of regions or if this is a subset right now. It looks like it's just a subset, but you can choose wherever you want. I typically choose somewhere closer to me, so it's either, I'm in Toronto, so it's either Canada Central or East US or East US 2. So it all depends on what works best for your organization. If I check off East US, I want to choose a mode to run the cluster. Typically, it's going to be a production mode. And then I can choose the number of servers. So here in this case, I can only choose 3. That's fine. And then, of course, I'm going to name this HCS beta cluster 4 as an example. Then I go on to the actual console specific settings here for the cluster. I can rename the cluster name here as well. So there's a whole higher level on the basic screen. This is the name that I'm about to fill out, is the name of the, oops, wrong screen. The name of the managed application down here, okay? And then in console settings, this is actually the name of the servers themselves. This typically you won't need access to. You're going to be accessing the cluster through the fully qualified domain name. So it's not big of a deal, but you should remember what it's called. As with most console deployments and configuration, you're going to name this data center. Of course, the example, the default is DC1. But you can rename this to whatever naming conventions that you have within your organization for your clusters. In the future, of course, you'll be able to choose your console version. Right now, it's set to 1.7.2, which is one version behind, so to speak. So right now we're at 1.8, I think, is the latest. So this is 1.7.2. You can disable the external endpoint. The external endpoint being the method of which you can actually view the console UI. Enabling it makes the console UI a public endpoint. For some organizations, that might be a concern. For the most part, it shouldn't be, because you still need the ACL tokens in order to actually do anything worthwhile with the portal, as well as the connection is secured over SSL or TLS. And as I mentioned before, you have the option to change the VNet IP range. As noted up here, the VNet starting IP range must fall within either a 10.0.0.0 range, 172.16.31.0.0 range, or your typical, if you're doing home networking, 192.168 range. And this shouldn't be done, without much thought. You should be considering, are there network ranges that are already in use? Am I pre-sizing this or pre-allocating this correctly ahead of time? So do keep that in mind. Once you've got these settings all set up, you go through review and create, agree to the terms of service, of course, sign your company away. And then what you can do is review the settings that are already set up there and then just hit create. One thing I want to note is that these value names are essentially available to you in the ARM template, as well as the Terraform Azure RM Managed Application resource. So these fields will be necessary for you to pass down into those particular resources or the template requirements and fill them out accordingly as well. While that's great, the one thing that is missing from it, because these are just parameters we pass to the resource group, there isn't necessarily the typical Terraform graph that's associated with it. So do keep that in mind when provisioning. Okay, so this will get passed down accordingly. So once this looks good, you can hit create. If you do need a template to redeploy this in other forms, you can click this download a template for automation, and there's different forms for you to take advantage of automating that process. Okay, so once you hit create, right now it takes, I think, it spun up for me in about 10 minutes or so. I'm not going to do that now because that's not an effective use of our time. We're just going to pretend that it went through, and we're going to leverage this cluster already created before. So this HCS demo beta 3. If we click on this, you'll notice that it's got it looks and feels like it's part of Azure. This is sort of the same layout for most other resources, virtual machines, Kubernetes clusters. Gives you some pertinent information about the actual resource that we just deployed. The key things that we want to take a look at for today are the parameters and outputs. So these are the settings that you'll have access to, the actual IP range that has been deployed for you. So in this particular case here, I'll use a drawing here. The VNet CIDR range is a /24. Seems kind of wasteful, but it's good. It's okay. It's all just software-defined network anyways. No hardware resources have been wasted. So so this is the actual IP addresses of the console masters that will be deployed on our behalf. We'll see other information like the console version number, storage account, and etc. that will be provisioned for us. So that's all good. The a very important one is this console URL. So this is the external URL that we can actually reach this cluster at. And in fact, if I just copy this and show you, I just open up a new browser window, I can actually get access to it. And the reason why you're already seeing these resources in here is that I've already entered in an ACL token into the portal. If I actually open up like a private window now, this will reload and it'll ask me or prompt me for an ACL token to do anything that actually is of worth. And of course, it follows the ACL policy. So if you don't have any rights to do anything with that token, nothing will happen really. All right, so that's all available here. The other things that I want to mention is that, yes, you can make that UI available over the public internet or with the FQDN listed down here. You can also use this setting here. Hopefully there's a feature in the future to change this logo or icon, but right now it's console UI. And if I actually click that, that'll actually route traffic to the same console UI that I just saw, but over an iframe within this portal itself. So which means that I can only get access to this portal, 1, if I'm authenticated to the Azure portal, and 2, I can only get access to services in here if, in fact, I have an ACL token as well. So an extra layer of security for us there. Going back to one other important detail, you'll notice here, I'm going to actually shorten this down, so I'm going to filter for HCS. You'll notice that there's this extra resource group here, MC Managed Resource HCS Demo. It's named after my cluster. So this allows me to see some of the resources, wrong one, sorry, MRG. This is the one that's actually the HashiCorp managed resource. This other one, MC1, is the Kubernetes cluster I deployed for this demo. The MRG one is the managed resource group deployed by HashiCorp. And what you'll notice, all the resources that gets deployed, depending on your access level, of course, with Azure, is visible here. All right. The thing that is most important when deploying your cluster is, I mentioned before, VNet peering. So the managed resource group that HashiCorp deploys on your behalf gets created in this resource group. Okay, it gets the VMs themselves, or the VM skill sets, network security group, application security group, the storage account where all your config settings and SSL certificates and things like that, I believe, are stored in there as well. The VNet is very important, of course, right? Because you can't communicate to console without the underlying network itself. So what you'll need to do at some point when deploying this is you click on that VNet or the VNet that you want to peer into. It's probably easier to go from here into your own VNet. And what you want to click is peerings. So you can peer multiple virtual networks depending on your topology of how you want to route things. But you can actually add additional peerings. So in my particular case, if I just go back up one for a sec, I've already peered this with the VNet that I wanted this to work with. Okay, but I could add additional ones, and so I can click Add, and through this UI, I can name the VNet peering in both directions. So that's important. The VNet peering isn't a one directional thing; it's bidirectional. So in this case, I'll name this one because it's from the managed HCS cluster. I'm going to call it managed HCS 2 private VNet. I choose the subscription that it's going to join with, and I get then within that subscription itself, I can choose the various virtual networks that I might have already deployed. Okay, so I'll just pick an arbitrary one, and then I'm going to name this the opposite direction, which is private VNet to managed HCS. This will configure access to the virtual network from both directions. I can disable it accordingly for whatever reason I might need to. I can also set up things like forwarded traffic. So again, depending on your network topology, if the traffic does not originate in the VNet that I'm peering with, and I'm doing an additional hop, maybe that VNet is a hub VNet, I'm doing additional hops in between to a spoke VNet, or like a sibling VNet that's kind of a leaf one off to the side, I can enable or disable that kind of traffic, okay? Or if I've got VPNs set up, all that is configurable here. So those are additional settings. And once I hit OK, it takes seconds for this peering to actually establish. And all that communication as a result of VNet peering happens across the Azure backbone. So again, if you're a security conscious organization, that traffic never leaves Azure. It never goes across the public internet. And of course, it's going to also be secure with TLS when talking to your console agents as well, right? So all that benefit is there. I'm not going to actually deploy this peering because it's unnecessary for me. But that's sort of the high-level way of deploying and just getting it set up into your network itself. Now, the next thing I want to actually show are some of the configurations that you get. So the portal itself gives you some of the information that you'll need, but the configuration that you'll actually need is well documented. So you can find that at learn.hashicorp.com/console/hcs-azure/configuration, and it'll actually go through the steps to actually teach you how to get all the pertinent configurations, settings, files that you need in order to successfully deploy your console cluster. The settings in particular that you need are the certificate authority public certificate, as well as the basic console config file. The basic console config file, of course, comes with the presumed sane defaults that you need to deploy the cluster, the encryption key for the gossip protocols, so for surf behind the scenes, as well as a couple other key things. The format that it comes in, you're going to see this. I've redacted some of this information for you, but it tells you the exact subscription or the exact ID for your particular deployment. It'll tell you the name of the cluster, all the information that you need to actually get access to it. You notice that the Consul certificate authority, the public certificate, is base64 encoded. It's quite a long one. You'll notice that you'll get your cluster ID, and you'll get also base64 encoded console config file as well. So you need to do the base64 decoding in order to get access to those values. If you're putting this directly into Kubernetes, of course, as a secret, which really isn't a secret, try to leverage something like Vault to make it truly secret, or like an Azure Key Vault as well. You could just pass that value directly in, depending on how you're deploying it. You'll notice all the other configuration settings we saw before, so that's not super important. But once you actually extract that in the terminal using like JQ or something like that to decode, and once I do base64 decoding, it'll show up as something like this. All right, so you get your encryption key, the data center name configuration that you would have put into the portal when deploying the service, and also the retry join address. So this is the FQDN. It's all load balanced behind this address to the actual console masters themselves. And this is what will actually communicate, or this is the FQDN that will be available across the VNet peering. Okay. The important thing here also is that depending on your organization, if you've got custom DNS set up, this peering may or may not be an issue for you, but that's something that you should consult with your particular service account manager or HashiCorp to figure out how can you actually route traffic, either with a custom DNS server or just leverage Azure DNS. So something to keep in mind. You'll also need to bootstrap the service, and there's documentation on how to do that on learn.hashicorp.com as well, in terms of to get access to the initial bootstrap token itself. Okay, so for anyone watching this in the future, I'm just going to delete this. So this is do not expose this, of course, right? Your global management token. Just keep that in mind. So that's all available to you. So essentially, what you need to bootstrap is all there. You can change the configuration files or modify them according to your particular organization's standards. Put them onto your agents, deploy them out accordingly, and then restart the agent themselves. You might have to delete the data directory because the node ID and things like that might not come up accordingly. But again, that's something for a future video to cover as well. Okay, so going back to the slides, that was supposed to be a short overview, but I think I've gone on long enough around that. We've gone through the HTS config files. Now I want to kind of talk about the general or the common deployment scenarios for this, right? So far left-hand side, console, the entire HashiCorp stack is a set of cloud-native tools. So if you're going to go full-blown, quote-unquote, cloud-native, putting in quotations because, while synonymous, Kubernetes containers is synonymous with cloud-native, right? Microservices and so on. It's not the only way to do it. So Kubernetes typically is the one that most organizations are moving towards. You might also be an organization that's fully virtual machines. HCS will work with that in that scenario as well. The documentation around deploying on VMs is there as well. You are more likely going to land on the right-hand side or a hybrid environment, right? It's not going to be all VMs. That slice of the pie might be shrinking, but it will likely always be there. Conversely, your slice of the pie for AKS or Kubernetes rather, so AKS is Azure's Managed Kubernetes Service. That slice of the pie might be growing. It might be small today, might be huge tomorrow, might be your entire pie tomorrow. I don't know. So that mixed environment is most likely going to happen. So the endpoint, again, that we're going to get to eventually is how do we actually have this happy synergy between both services? How is this going to work? We'll come back to this in a sec. Just going to take a quick look at this environment. You'll notice that I'm putting just these two side by side. I can put the third one on here as well. The configuration is essentially the same. The only difference here, though, is that the virtual machines themselves have a one-to-one relationship with the underlying proxy, Envoy in this case. In the cluster scenario, or the Kubernetes cluster scenario, Envoy is going to be launched as a sidecar process. So for every pod that you have, you're going to have an Envoy proxy with that particular service. Okay, so in a lot of cases, this is advantageous, right? You don't have to really manage or maintain it. It's all just configuration, and you get this awesome inject console connect inject annotation that puts the sidecar in for you. On the other side, it's a little bit more, I would say, not performant necessarily, although your mileage will vary depending on your virtual machine, depending on your containers and the size of the VM that you're running things on. But it is a little bit more efficient in terms of resource utilization, because in the Kubernetes cluster scenario, because it's a one-to-one for every pod essentially, you're not going to get the same amount of density, and it's going to eat up some resources. So you have to really think about what type of resources you're using and then size accordingly. The scenario is the same. You're going to have a local console agent, which will communicate to the control plane, right? Your console primary cluster, your masters. Those will get configuration pushed down to them, and then your local agents will communicate with the proxy to set up, certificates, the policy, the rules, policies in the console. Lingua franca is intentions, right? Can application A talk to application B, and C can't talk to B, etc. Right? So we're familiar with that. In the service mesh scenario for a mixed environment, essentially the scenario is the same. The pods and the VMs don't actually know that one service could be in a container or the other service is fully in a VM. They're only communicating to the local proxy, or Envoy in this case, and Envoy itself will broker or set up the secure communication between the two endpoints. So from the perspective of the service itself, of course, it thinks it's talking to localhost, right? In which it is. It's talking to Envoy locally. And then Envoy will transmit the communication over the network to your actual service on the other end of the communication. So in terms of migrating your service, which is the endpoint that we're trying to get to, is that you don't have to migrate everything, right? You can migrate things that make sense. In some cases, you have applications, maybe there might be a legacy like .NET app, if you're still using .NET, full, standard, whatever you want to call that. And it has a certain dependency, or it's pinned to a very specific version of the underlying server, or the framework itself cannot be upgraded or modernized without a lot of heavy lifting to something like .NET Core, which could be deployed on Linux. So you are coupled to Windows Server. So in that case, you'll have to leave that service on the VM itself, or maybe it might be back on-prem. So, but you do have access to communicate on the local machine with TCP. You can choose a port, or in some cases, you can choose sockets depending on how your app is actually developed. And again, the communication will go be brokered through Envoy. You'll get TLS or MTLS out of the box, and it'll be secured across, and your services themselves can identify each other with MTLS. So lots of advantages there. Again, the services will never know the endpoint if it's on the local machine, if it's in a remote compute on the other side of your network, back on-prem, doesn't matter. From the perspective of how these would work with one another, again, the easy part is actually deploying Consul. Arguably, it's the easy part, depending on your experience with it. Setting up the configuration, deploying the proxy, etc., and then it should go. The hard part is if you're trying to grow your footprint into Kubernetes, or conversely, you're trying to shrink your footprint in VMs. So how can you actually do that deployment in a relatively graceful manner, and in a manner that doesn't necessarily, let's say, constrains you to doing it the Consul way? Because if your engineering team, or your reliability engineers, or cloud operations team, or whatever you've named them, their sort of configuration tool that they prefer is Kubernetes manifests, or Helm charts, etc. Wouldn't it be easier for them to actually operate or create intentions or traffic splitting and all the, and metrics, etc., in a Kubernetes native way? And so to transition this, of course, to the next version, to split traffic between maybe services that are currently living on virtual machines, and some are being, instead of adding more virtual machines to your infrastructure, you want to actually add more instances inside Kubernetes while still keeping the VMs, the current processes running on VMs alive. Wouldn't it be great if you can just split traffic to version 1, which are on VMs, to version 2 or 3 or 4 or 10 in Kubernetes, or have some kind of weighted traffic accordingly for that? So Consul does have traffic splitting built into it. You can actually create those policies, those rules using HCL and create it based on weight. And that works fantastically. What would be even better is, again, going back to the Kubernetes example of if we put something on top that can translate Kubernetes' native way of doing it to the actual underlying service mesh implementation. So in this case, Consul and its traffic splitting or metrics or all the other things that you would get with it instead. And so if I just jump ahead, because getting short on time, make sure I want to have some time for Q&A. I want to introduce or talk about service mesh interface to help do this migration from VMs to Kubernetes cluster. And so this will help with the hybrid scenario. It allows you to do traffic splitting, all these different pieces for you. So I'm just going to jump back into the browser. Hopefully this shows up accordingly. So HashiCorp Consul supports service mesh. It's an open spec made by us at Microsoft, or more importantly, our upstream open source team that came over from a company called Deus. So they're by and large led by a gentleman, Lockie Evenson, if you might met him. There's a bunch of people on that team, Michelle Norley, etc. They help to create all these open source initiatives coming out of Microsoft, especially in this cloud native space. And so the spec is meant to define a common interface or a common set of things that a service mesh should have, which allows you to write in a Kubernetes native way and then have that resource, the controller, translate that down to the underlying service mesh's implementation. So, not that you probably want to get out of it, but if you needed to change between service meshes, maybe you're early on in terms of choosing which one is right for you, service mesh allows you to have a little bit of an escape hatch in that sense with the 4 common sort of things that service meshes typically would have. More importantly, though, is that it gives you the ability to add on additional tools on top of your service mesh that you wouldn't normally have without having to be tightly coupled to the underlying implementation. So you can have things built on top, things like Flagger if you're using it, that knows how to speak the service mesh interface, but doesn't necessarily know how to speak Consul's way of doing traffic splitting or policy, etc. So this gives you a lot of flexibility. You can continue using the broader ecosystem and be able to switch things out. So not to spend too much time on this, there is an SMI controller that's available for you to try out with some policy. Nick Jackson has got this out here. It's quite good. It's I believe it only supports at the moment access control. There is a spec for traffic splitting in here as well. It pretty much looks very much like traffic splitting with a Consul itself as well. You can read more about how to do traffic splitting specifically with Consul implementation. That's on learn.hashicorp.com. If you're interested with the SMI spec and how to actually take advantage of it a little bit further, how to actually use the Go SDK for it. So if you wanted to monitor the CRDs that are deployed inside Kubernetes to monitor, maintain, and then decide what you want to do within your organization, that's also available to you as well. All right. So next steps, of course, check out learn.hashicorp.com to see how you can actually deploy HCS from end to end. Check out SMI spec to see the evolution of SMI. Right now it's at, I believe the SDK of the API is at Alpha 3 right now. In the future, we'll have a proper walkthrough of how to actually deploy this and what that migration path looks like in terms of going from a purely VM service that's leveraging Consul to a mixed environment to how do we drain everything over to Kubernetes altogether if we need to. All right, so leveraging SMI in there as well to maintain our policies and the traffic weighting and routing accordingly. So that's it. I want to make sure we leave some time for questions. So Chris, I'm going to stop sharing for now. I'm going to switch to video instead. Any questions on the line?
Yeah, no, Ray, thank you so much for the walkthrough today. Very helpful. For all of those that are on the line, there's quite a few questions that came in. Yes, we will be making this recording available. We'll be able to send it out to everyone. You'll also be able to find it on the HashiCorp.com website. And then in addition to that, we've got a lot of different resources, as Ray was just mentioning, across our learn.hashicorp site properties, and there will be continued different pieces of content, technical guides, walkthroughs, other videos, all embedded on some different Azure properties as well, to see all this stuff come together. So keep an eye out. We will be sending all that stuff out. So Ray, I want to go back in a couple of questions. There was a first part of the demo that you were going through where you were working with some of the IP addresses, and some of the big questions that came up was, can an IP address be changed after its initial creation? And if so, what are the normal steps that you would take to go through that?
So I presume that means the IP address of the actual Consul cluster itself?
Yes.
Yeah, so that would have to require a redeployment of the actual cluster itself, because you don't have that ability to basically change the underlying VNet. You don't have access to that resource that's managed for you on your behalf. That might be something that HashiCorp engineering could support you with, but typically that's not a scenario that you would be able to do, even if you own the VNet yourself in Azure. You'd have to do a full migration over to a new VNet. You can't do a VNet update in place. You can add additional subnets to it, or add additional IP ranges to what's being controlled, but you wouldn't be able to change the actual subnet or IP range.
Awesome. Thanks, Ray. Another question that came in was just kind of getting back to some of the basics. So for somebody who's kind of first getting their feet wet into spinning up their first AKS cluster, just the general question was, what are some of the best practices around spinning up your first cluster and kind of ways to leverage AKS and HCS together if you're doing this kind of for the first time?
So the easiest way to get started is to take advantage of the Consul Helm package that's available to you. So I believe that if you're using Helm 2 or 3, the repo is HashiCorp /Consul-Helm. And what that will allow you to do is two things. One, you don't need HCS. So if you're not ready to take advantage of the managed service, or if you want to roll your own, and in a purely Kubernetes way, just to test out, you can use that Helm package to actually deploy your master control plane inside of AKS. Secondly, if you already have a Consul cluster running, either in a sandbox environment, or you want to go full extreme and attach it to a production service or a production cluster that's already running, you could use that same Helm package, Helm chart, to connect your Kubernetes cluster to that control plane. Or if you do want to spin up HCS, and then you'll get the config settings that I showed you earlier in the presentation. Use those settings to actually put into that Helm chart as values, and then basically connect your cluster without masters inside your AKS cluster to the HCS service as well.
Awesome.
So, yeah.
Cool. Thank you, Ray. And then actually back on the topic of IPs, there's a couple of other questions that had come in around this. And looks like the general consensus is, how do you actually decide the IP ranges before creating the cluster?
Yeah, one, as you saw, at least in the beta, the range is going to be a /24. You don't have, I don't believe you have control over anything smaller than that, even though your cluster is going to be 3 nodes as of right now in the beta. That might change in the GA, but they'll be documented accordingly. So keeping that in mind, you'll need a /24 of some sort. So in order to figure out what you have, you'd have to do an inventory of the VNets that you currently have deployed within your organization. And that should actually include VNet or IP ranges that are on-prem as well. Depending on your organization and the size of it, you likely are peering or through a technology called ExpressRoute, or maybe a VPN connecting back to on-premises. So you want to make sure that you don't have any overlapping ranges. So if you have let's say a 192.168.0.0/24 on-prem, you want to make sure that that is not being used as the address range for your Consul cluster as well.
Awesome. Thanks, Ray. And that actually takes us to our allotted time today. We had about 45 minutes carved out for everything. There were a couple questions we weren't able to get to. As Ray was mentioning, we will be doing more sessions as time goes on, and there's going to be a lot of additional information that's coming out around HCS on Azure as soon as we GA, which will actually be the 23rd, so just a few days away from today. If you do have immediate questions, feel free to reply to Ray. I know he shared his contact information. Of course, us over on the HashiCorp side, we will be sharing this presentation out. Feel free to reach out to any one of us or your solution architect that you're working with across the Azure teams and HashiCorp teams, and we'll be more than happy to answer some of the additional questions that come up. But again, Ray, massive thank you for the partnership, for the great walkthrough today, and thank you everybody for attending. We really appreciate you guys checking out our partnership and some of the new integrations that we're working with HCS and the great folks over at Azure.
Thanks, Chris. Thanks, everyone.
Thanks, Ray. Thank you, everyone.